All right, so we're talking about your test here today, and so there's the free response from the test, specifically is what we're going to be going through right here. And there were a couple of errors on them, the first one being on part A, where it says show that the derivative is equal to this, and unfortunately that is the incorrect derivative. I do apologize for that. We are going to use this for the rest of the pieces, though, because it is much easier to use than the actual derivative. But we're going to go ahead and take the derivative implicitly of this. So we've got 6x squared times dx plus, this is a product, so the first times the derivative of the second, dy dx, plus the second y times the derivative of the first 2x, dx, minus 2y dy dx equals the derivative of 2, which is 0. And so there's my problem. I'm going to clean it up a little bit. I've got 6x squared plus x squared dy dx plus 2xy minus 2y dy dx. The dx dx is all making 1. Now, based on the fact that the 2y is positive over here, I'm going to go ahead and the x squared is negative. I'm going to go ahead and move these to the other side. So they're going to move to the other side of the equation. And we will have 6x squared plus 2xy equals negative x squared dy dx plus 2y dy dx. Factoring out dy dx gives me 2y minus x squared equals 6x squared plus 2xy. Finishing off, we will divide both sides by 2y minus x squared. And then my final answer, dy dx, equals 6x squared plus 2xy over 2y minus x squared. This, of course, being the slightly wrong answer because the answer does not have 2x in it. So I do apologize for me clearly not being careful when I was taking this part of the derivative when I made the original answer key. But so this is correct, and if you wrote this down, I did give you full credit for that. Some of you tried to adjust and remove this. I tried to be cognizant of that. This mistake here is the real reason you are going to retake this. I know that getting it not correct when you were told to throws everything off. It makes you think you're wrong. And so then, but as we move forward, we're going to take the second derivative of this one just to be consistent, just to save ourselves some trouble. So we're going to go ahead and take the derivative of this using the product quotient rule. So we've got down 2y minus x squared. Make sure it's in parentheses. D up 12x plus dy dx. Make sure that's in parentheses. Minus the up low d high minus high d low. Again, in parentheses, derivative of the bottom, 2 dy dx. Let me get a rectangle over here going 2 dy dx minus 2x all over the bottom squared, 2y minus x squared squared. So I'm not going to bother to simplify this at all. I'm going to leave it right here. I don't need to simplify it. I am going to go ahead now and plug in this point. Also, another error, which probably you didn't notice at all, is that this point is not actually on the original curve. This is a problem because it should really be on the original curve, but we're going to ignore that for a minute. I'm actually going to start by, let me back up half a second more, equals to the d squared dy dx squared, anyway, the second derivative. I'm going to go ahead and evaluate dy dx at the point first, because it's kind of a complicated little mess. -1, -2, which gives me 6 times -1 squared minus, plus, -2 over 2 times -2 minus negative 1 squared, which becomes 6 minus 2 over negative 4 minus 1, which is 4 over negative 5. So that's dy dx. When I show for dy dx, I'm going to plug this in, negative 4/5 for dy dx. Okay. Next, I'm going to go ahead and just plug in the numbers that I saw. 2 times negative 2 minus negative 1 squared. 12 times negative 1 plus negative 4/5 minus 6 times negative 1 squared minus minus negative 2, so plus 2, parentheses 2 times negative 4/5 minus 2 times negative 1, close parentheses, all over 2 times negative 1, negative 2, minus 1, negative 1, squared. You'll notice I really didn't do anything here when I plugged it in. Just kind of plugged and chugged away. That's my answer. I'm going to stop right here. This is it. And of course, I mean, if I want to get a little technical, I should say that that's equal to, and I'll just put it up here, equal to 2 dy dx, the second derivative evaluated at negative 1 comma negative 2. I want to get technical, that's what I should say. This is good enough. And you can keep going and go to an answer, but you do not have a calculator. This answer is going to be ugly. This is good enough, and you can stop. Because what happens is we start to work forward, we start to make mistakes. The biggest mistake of people who were evaluating this is very, very, very few people actually found dy dx. Most of you left that in your final answer. You need to find value for that. That was the biggest mistake made on this. The second biggest mistake was not getting the derivative right. So if you don't have the derivative right, and some of you used the derivative you found in part A, that's fine. If it was correct and you went ahead and used that, you made the problem a lot more complicated with that. So I do apologize for that being there. But this is, like I said, enough. Make sure you're replacing dy dx. That's probably the biggest issue here. And finally, we have our final question. So this one also had a mistake in it. It was find the x-coordinates of any horizontal asymptotes, which means you'd be looking at the end behavior and therefore finding the limit at infinity, which we don't know how to do of an equation that is not already, that's not a function. We don't know how to look at the end behavior. We don't have to think about the limit that way. We're not really quite prepared to think about, okay, so what's y doing at x is getting really large and y is sitting next to x. It's a little confusing that way. But that's how you would have to find the horizontal asymptote. There aren't any. The reason being that as x gets very, very large, y gets really, really small. And as x gets really, really small, y gets really, really large. And I only know that by looking at the picture. So, but what this was supposed to say is find the x-coordinates of any horizontal tangent lines. Now, if anybody had correctly explained horizontal asymptotes or found the vertical asymptotes correctly, which some of you tried to do vertical asymptotes, anybody had done that correctly, I would have given them credit for that because the question was poorly phrased, but this was supposed to be tangent lines, which is what I'm going to show you. And then I will also show you how to do vertical asymptotes at the same time. So we're going to do both of those because either one of those is fair game. This is what you're going to see on the redo. So for horizontal tangent lines, it's when the derivative is equal to 0. And so that will be when the numerator is equal to 0. Or in other words, where y equals negative 6x squared. And then we're going to plug this back into our original equation. And see, this is where it becomes a problem because this is not the actual derivative, and so we have all these issues. We're going to ignore that for a minute. We're going to go ahead and plug back into this equation right here. And 2x cubed, x squared, y, negative y. Okay. 2x cubed, x squared, y, I think that's positive. Yep. Minus y squared equals 2. So we're going to plug this into that wherever we see y. So we will have 2x cubed plus x squared minus times negative 6x squared minus negative 6x squared to the fourth equals 2. And we can solve this equation now. 2x cubed minus 6x to the fourth minus 36x to the, excuse me, that's supposed to be squared, I was thinking ahead, to the fourth equals 2, which is negative 42x to the fourth plus 2x cubed equals 2. And then we're trying to figure out what the possible answers could be. That's why it's only asking for the x coordinates, because you're just trying to find x. There are no horizontal tangent lines. This will never be an answer. It gets pretty complicated why, but the picture, so again, I looked at the graph to kind of explain it to myself. The picture of this looks something like this. There is a vertical asymptote. So that's why but we won't be able to find it with our method because we have the wrong derivative. Although the denominator of our derivative is correct. So we can find it. It'll be good enough. So sorry about that error. I hope it doesn't actually interfere with the video too much. I've been having issues today. And so I'm going to try to start over from this point. So what we're going to do now is treat it with if it had said vertical asymptotes instead of horizontal asymptotes. So let's pretend it was vertical, because that's one of the two questions I'll be asking you on the test. And so if it's vertical asymptotes, it's where the denominator equals 0, because then the slope will be undefined. And so that happens 2y equals x squared. And so that happens when y equals x squared over 2. So the same thing that we did before, we're going to substitute y. With x squared over 2. So 2x cubed plus x to the fourth divided by 2 minus x to the fourth divided by 4 equals 2. And so those are the same. So I've got 2x to the fourth minus x to the fourth over x to the fourth. 2x squared equals 2. 2x squared cubed plus x to the fourth over 4 equals 2. I'm going to times everything by 4. 8x cubed plus x to the fourth equals 8. And then I'm going to check and see roots, but the first one I'm going to check is 1. If I plug in 1, that's not going to quite work out. It's close though. So I'm going to go ahead and look at the picture of the original. And so I had 2x cubed minus plus x squared y minus 2x y squared equals 2. If I know it equals 2, I just don't remember if I know the whole equation. Yep. Okay. Okay, I lied. There isn't one. Actually, if there is, it's up here. There it is, right there. About negative 18. So it's not going to work out really nicely. The one on the other version, I was, like I said, much more careful about it. It has one. We would have to check it. We plug it in, we'd find out it's negative 18. A problem like this, they wouldn't give you without the calculator. X coordinate, that's it. So that's vertical. And again, this whole plugging in. And so what I'm looking for is, one, you know what to do when you read the words, you know which do I set the numerator equal to 0 or the denominator equal to 0? Or if I'm trying to prove that and some of you said that there's no way we was going to have a vertical asymptote or horizontal asymptote because it was in a fraction in the original problem. That's cool, except for that it was y, and I'm out of time. and we'll talk more.